In this video, we're going to talk about inverse trig functions, and we're going to talk about the tangent. So the graph of the tangent is not one-to-one because each of these cycles repeats itself, and it wouldn't pass the horizontal line test. However, if we restrict the domain, then, oops, and this is a mistake. If we restrict the domain to pi over 2, like so, then we can take the inverse. On that interval, the function is increasing. You can see that. On that interval, it takes on its full range of values from negative infinity to infinity. You can see that as well. And on that interval, it is a one-to-one function. So here is our definition of the tangent. The inverse tangent is defined by the inverse tangent, tan to the negative 1, or arctangent if and only if the tangent of y equals x, where x is between negative infinity and infinity, so all real numbers, and y is between negative pi over 2 and pi over 2. So the domain of the tangent is all real numbers, and the range is negative pi over 2 to 2. But just recall it's not inclusive, so be careful with those symbols. All right, let's talk about the arctan of negative 1. So here you might have to do a little bit of thinking back to where your relationship of sine and cosine helps you with tangent. So remember, sine of theta over cosine of theta equals tangent of theta. So in order for us to get negative 1, we need to have a sine and a cosine that are opposites of each other. So they're going to be the same values but opposite signs. The only place where that happens is at 45 degrees or at that pi over 4. Since we want it to be negative, then we must be talking about something that's in the fourth quadrant, because in the fourth quadrant our x's are positive but our y's are negative, and since tangents are only going to be in the first or the fourth, and in the first they're both positive, we know that we must be talking about 45 degrees in the fourth quadrant, which would be the same as negative pi over 4. All right, example B. For this inverse tangent, if you unrationalize it, you can get it back to this stage. And that stage, if you undo that one more, is going to be the 1/2 over root 3 over 2. So we know that we're talking about a sine of 1/2 and a cosine of root 3 over 2. Well, a sine of 1/2 occurs at pi over 6. These are positive values, so we're going to be at in quadrant 1, so we will have the answer pi over 6. For the inverse cosine root 2 over 2, I slipped in a cosine here, so just be aware. Root 2 over 2 is at 45. We already talked about that, which is the same as pi over 4. And then example D, the arctangent negative root 3. So working backwards, this is the same as root 3 over 1. That would be the same as root 3 over 2 over 1/2, but it's negative, right? So we know that we're talking about something in the fourth quadrant here. So we've got either we need to figure out what the sine is at root 3 over 2, or we need to figure out what the cosine is at 1/2. And if we do that, we get pi over 3, but it needs to be in the fourth quadrant, so we're going to call it negative pi over 3. You can also use your CAS in order to evaluate your arctan functions. It's the same button. It's the trig button. So you just hit the button that says trig, and then you choose the appropriate value, and then you hit enter. Make sure that you are in radian mode if you are given radians. So go ahead and take a second with your CAS and practice those. Pause the video and then see if you got them right. All right, here are the answers to those values. Just notice the last one, your CAS probably gave you a message about having a non-real answer. So that means that the value is undefined. Okay, great.